Okay, let's just dive right into this. Welcome to today's explainer. So, today we are going to unpack this genuinely fascinating piece of communication from the educational series Sparky. Now, if you're already familiar with systems thinking, you might be sitting there wondering, wait, why are we analyzing a lesson built for kids? Well, the reason is actually pretty simple. Distilling super complex system dynamics into a completely mundane plumbing issue is an absolute masterclass in communication. We're going to look exactly at how the creators of this show strip away all that dense, boring academic jargon to uncover the really elegant, irreducible logic of accumulation. It completely proves that the absolute best way to understand massive, global, macro-level systems is to start with something totally ordinary.
So to set the stage for all this, let's look at episode 5, which is called The Hidden Energy Pipes. Right out of the gate, the episode hooks us with this super relatable physical premise. Sparky is looking at a rather wet problem. Why is the bathtub overflowing? Starting with this specific, messy little micro problem is honestly a brilliant hook for macro system analysis. Think about it. It takes something that usually requires, giant whiteboards and crazy complex mathematical modeling, stuff like system equilibrium, and it just scales it all the way down to a closed environment we've literally all experienced. It's just a simple, everyday annoyance. But Sparky's investigation into this stubbornly overflowing tub is basically the perfect Trojan horse for teaching structural dynamics.
Because, right, this isn't just about a plumbing emergency. This simple, sloppy scenario is actually a brilliantly disguised metaphor. The creators specifically designed this to teach the foundational principles of systems thinking, and I gotta say, it works incredibly well for advanced audiences too. Why? Well, because grounding abstract concepts in physical reality totally bypasses that mental friction we usually get when we try to learn about system dynamics. I mean, when you start talking about abstract nodes and feedback loops, people's eyes just naturally glaze over, right? But when you talk about a tub full of water, we inherently understand the physical limitations of that space. The water acts as this tangible proxy for abstract resources, making the invisible forces of a system suddenly very, very visible. So let's break this system down into two opposing forces. On one side, we've got the inflow, that's represented by the faucet, just pouring water into the tub. And on the flip side, we have the outflow, the drain, letting all that water escape. The entire system is essentially this physical head-to-head battle between these two variables. In system dynamics modeling, these are your primary drivers. You really can't understand a stock market, a supply chain, or a digital network until you first identify the mechanisms bringing resources into the environment and the mechanisms pulling them out. Understanding this basic structural tug-of-war, that is step one in mapping literally any complex system.
And the sequence they use to guide the viewer through this is incredibly deliberate. Step 1, observe the inflow. Step 2, observe the outflow. And step 3, track the accumulation. What's so fascinating here is that this isn't just a how-to guide for a bathtub. This is literally the fundamental algorithm of all systems analysis. Whether you're an engineer looking at a highly fragile national power grid or a logistics manager just trying to unblock a massive global supply chain, this is your diagnostic sequence. By systematically isolating and distinguishing between these competing forces, we can start to accurately measure how a resource either builds up or depletes over time. It's basically a universal diagnostic protocol, just cleverly disguised as child's play.
Then, the episode does something really clever. It pauses for a moment of interaction. It directly asks, if more water comes in than goes out, does the water level go up or down? Framing this as a direct question is just a really smart teaching tactic. It's not actually about testing whether you know the obvious answer. It's about forcing the brain to actively map that relationship between input and output. Even though the answer is totally clear, the simple act of predicting shifts the viewer from just passively receiving information to actively modeling the scenario in their own mind. It forces you to mentally simulate the mechanics of the system before they even confirm the outcome. And of course, the water level goes up, right? It's a simple revelation in the context of a cartoon story, but the implications are massive when you scale them. This interactive moment really helps viewers visualize system thresholds and failure states. Whenever the input of a system continuously exceeds the output, systems don't just magically grow forever, they eventually break their boundaries. The water literally has nowhere else to go but up, and eventually, right over the sides. Whether that's an overflowing tub, an overloaded computer server completely crashing, or a city's infrastructure failing under rapid population growth, exponential accumulation inevitably leads to a threshold breach. So, once the physical reality of the bathtub is firmly established, the source material pulls off this crucial abstraction. It transforms that wet, messy, specific scenario into a crystal clear, abstract visual representation. The water tank diagram. This is the exact moment the lesson evolves. It takes the concept away from just being a specific story about a character named Sparky and turns it into a totally versatile, universal tool. By stripping away the faucet and the drain and swapping them out for a generalized tank, you're given a mental framework that can actually be used to map out practically any dynamic environment on Earth.
But the real brilliance lies in exactly how this stock and flow diagram communicates data visually. The tank features this massive, bold arrow pointing in and a tiny little arrow pointing out. This use of visual asymmetry is incredibly powerful. By simply altering the weight and size of those arrows, the diagram completely bypasses the need for any complex math. It communicates rate of change instantly, directly to your visual cortex. You don't need a spreadsheet to calculate the delta here. The totally disproportionate arrows trigger this immediate gut-level understanding that the system is imbalanced and the tank is filling up super rapidly. It's data communication stripped down to its absolute most effective core.
Which brings us right to the fundamental axiom of the entire episode. Accumulations happen when the in is bigger than the out. I really want to anchor our explainer around this quote because it is the irreducible truth of system dynamics. It sounds deceptively basic, I know, but ignoring this exact, simple truth is precisely why massive companies go bankrupt, why supply chains totally collapse, and why ecosystems degrade. When decision-makers fail to accurately measure their system's true inflow against its true outflow, they are literally inviting disaster. It is the grand, structural takeaway of the lesson, and it's applicable at every single level of industry and science. So let's formally define this just to fully solidify that grand takeaway. Accumulation is a buildup of resources that occurs whenever the rate of entry surpasses the rate of exit. And the reason this framework is so critical for us as adults is that this exact dynamic governs some of the most stressful parts of our professional and personal lives. Think about your email inbox for a second. It perfectly mirrors a block drain. If the rate of new emails coming in outpaces the rate at which you can actually read and delete them, you experience a massive digital accumulation. Or consider a warehouse. If manufacturing turns out products faster than the sales team can move them, the warehouse fills up, tying up millions in dead capital. Any system involving resources moving over time is absolutely hostage to this exact balance. Which brings me to a final thought I want to leave you with today. Where else do you see hidden inflows and outflows causing accumulations in your daily life? Now that we've decoded the absolute brilliance behind Sparky's bathtub logic, I challenge you to look around and audit your own environments. Apply this lens to the complex systems you encounter every single day. For instance, if your personal stress is accumulating, what's your primary inflow? And honestly, more importantly, how can you widen your outflow to release that pressure before you hit a failure state? It's a really fascinating, highly clarifying way to view the world. And it all starts just by understanding the hidden mechanics of a leaky faucet.